Good afternoon and welcome to today's session on integrating ISV identity providers with Amazon Managed Grafana. My name is Sunil Ramachandra. I'm a senior solutions architect here at AWS. Before we get started, I want to take a minute to thank you all for taking the time to attend this session in person. And my promise to you is, by the end of this session, you'll walk away with three concepts. One, what is observability and what is Amazon Managed Grafana? Why would you want to use Amazon Managed Grafana for your observability use case? And three, how to use Amazon Managed Grafana and how can it help you achieve the end goal of simplifying your observability journey on AWS. With that in mind, let's get started and take a look at the agenda. We'll start off with an observability overview. Then we'll look into some of the benefits Amazon Managed Grafana has to offer. We'll look into some of the use cases of Amazon Managed Grafana. Next, we'll dive into the various identity provider or IDP integrations available with Amazon Managed Grafana. I'll have a short demo, and finally, we'll wrap up the session with some key takeaways and resources for you to explore. Now, taking a step back from the technical world, let's try to first understand what the word observe or observation means. As the great martial artist Bruce Lee once said, if you observe with undivided awareness, you can even find solutions to life's most complex problems. Now let's try to tie the same principle to the technical world. Gartner defines observability as an evolution of monitoring that lets you gain insights into your digital applications, which can then help you innovate faster and further enhance your customer experience. Observability lets you understand what's happening in your system and gather actionable insights, often by instrumenting the system to collect logs, metrics, and traces. Once you have the access to this data, you are now better equipped to define and understand your service level agreements, KPIs or key performance indicators, and your response time and uptime requirements. Now let's look into some of the components of observability. Once you have instrumented your system to emit and collect the logs, metrics, and traces, you want to detect what's happening in your system by setting the right alarms or defining thresholds on your metrics, and also configure downstream notification channels, which can then involve your appropriate stakeholders or operations team. Next, you want to investigate why did a particular alarm go off or what metrics were being breached at a particular point by analyzing your logs and traces. Finally, by gathering data from these two steps, you can now remediate the problem or improve your system's performance by taking the relevant actions. Moving on, let's see how Grafana fits into this observability space. I want to take a quick pause here and ask the audience, how many people in the audience have used Grafana or have heard about Grafana? That's great. Hopefully this session will help you enhance your use case on Grafana and Amazon Managed Grafana. And for those who haven't heard, Grafana is a popular open source visualization platform that lets you combine data from various data sources, no matter where they live at, and visualize them in a single pane of glass in real time without actually moving or storing the data on Grafana itself. In 2020, AWS partnered with Grafana Labs to launch a fully managed Grafana service called as Amazon Managed Grafana. Using Amazon Managed Grafana, you can analyze, monitor, and set alarms across various different data sources. And these data sources can live within AWS or they can exist outside of AWS as external third-party data sources. Via AWS Marketplace, you can then upgrade to Enterprise Grafana to gain access to enterprise plugins. Since Amazon Managed Grafana is a fully managed service, AWS does all the undifferentiated heavy lifting of your operational management, such as taking care of your auto scaling, patching, or version upgrade needs. And Amazon Managed Grafana also integrates with multiple AWS services like CloudTrail for enabling and checking your API logs, or AWS Single Sign-On service for authenticating into Amazon Managed Grafana. And finally, Amazon Managed Grafana follows a simple pay-as-you-go billing model without any upfront costs. Now, as you can see, Amazon Managed Grafana supports all these data sources. Some of them are native to AWS, like Amazon Managed Service for Prometheus, Amazon CloudWatch, AWS X-Ray, and many more. Amazon Managed Grafana also let you get data from enterprise plugins like Datadog, New Relic, Snowflake, Splunk. By gathering all this data from all these different sources, you can then visualize them into dashboards. Now let's look at some of the use cases of Amazon Managed Grafana. By using Amazon Managed Grafana, you can query all the data sources we just saw to correlate metrics, logs, and traces from these data sources, and then visualize them into a single pane of glass for your operations team to collaboratively troubleshoot the issue. Some of the popular use cases of Amazon Managed Grafana we have seen is some of our customers, when they use their Kubernetes cluster or Amazon EKS or ECS, they publish their metrics to Amazon Managed Service for Prometheus, or they could publish the trace data to AWS X-Ray or Amazon OpenSearch, which can then be used as data sources within Amazon Managed Grafana to monitor your containers. Another popular use case of Amazon Managed Grafana is we have seen customers who are using IoT services can then publish their data from their sensors, power plants, or edge devices into AWS services like AWS IoT Sitewise or Amazon TimeStream, which can then be used as data sources within Amazon Managed Grafana to visualize and monitor your IoT workloads. Not only for your operational needs, Amazon Managed Grafana provides tracking into software development lifecycle and incident monitoring since it plugs in with data sources like ServiceNow and Jira. Thereby, collecting all the data from all these different disparate data sources, you can then achieve an unified observability solution using Amazon Managed Grafana. All right, until now we saw what observability is and what Amazon Managed Grafana is. Now let's see how to authenticate into Amazon Managed Grafana. Today, there are two ways in which you can authenticate into Amazon Managed Grafana. You could use the AWS Single Sign-On service, or you could use the SAML 2.0, which is an industry standard for most of the identity providers. Using either of these approaches, you can then integrate with your choice of identity provider, thereby enabling your users to log into Amazon Managed Grafana console by using their existing login credentials without having the need to create any new IAM users or use any other security mechanisms. Now let's look into the option one, that's authenticate using AWS Single Sign-On. If you're already using AWS Single Sign-On in your use case, this solution fits right in. You can just simply integrate your AWS Single Sign-On into Amazon Managed Grafana natively. Or if your use case demands, you could still integrate an identity provider with AWS Single Sign-On and then gain access into Amazon Managed Grafana. Now let's look into a couple ways, or let's double click into this integration and see how do we configure this. Typically, your user with an admin access would log into one of these identity providers and search for the AWS Single Sign-On app, and then configure the connection between the identity provider or IDP with AWS Single Sign-On by exchanging the necessary metadata and sign-in URLs. Once the configuration is complete, you can now sync your users from your IDP side into AWS single sign-on using SCIM. SCIM stands for System for Cross-Domain Identity Management, using which you can replicate your users from your choice of IDP into AWS single sign-on in real time. Once the users and groups are replicated into AWS single sign-on, you can now integrate them with Amazon Managed Grafana. This approach also allows you to use ABAC, or also called as attribute-based access control, for fine-grained controls. Once this integration is set up, there are a couple ways in which you can access Amazon Managed Grafana. You can log into your identity portal, search for the AWS single sign-on tile, click on it, and then you would be redirected to Amazon Managed Grafana. Or you could start off from the Amazon Managed Grafana workspace URL, and then you would be redirected to your identity provider portal, where you would enter your IDP credentials, and then you would be given access to Amazon Managed Grafana. While this option works great, we didn't want to stop there. We wanted to meet our customers where they were at based on the choice of identity provider. And we received a lot of customer requests for Amazon Managed Grafana to support direct SAML 2.0 integration. What this would mean is our customers could then use their identity provider as a single source of truth to seamlessly log into Amazon Managed Grafana, while they can continue to use their existing corporate directories for mapping users, permissions, and roles. In order to cater the customer requests, we came up with this second option called as Authenticate via SAML 2.0. I want to take a quick pause here and ask the audience, how many people in the audience are today using one of these identity providers for your use case? That's great. Now this would simplify your use case for Amazon Managed Grafana. You can log into your identity provider and search for the Amazon Managed Grafana co-built app. In order to further enhance the customer experience, we partnered with the leading identity providers like Okta, Ping Identity, OneLogin, and CyberArk, so that these identity providers could build a dedicated SAML 2.0 app within their respective identity provider portal or application catalog. What's also unique about this integration is Amazon Managed Grafana uses just-in-time provisioning, which uses SAML assertions from your identity providers behind the scenes. What this means is you do not have to assign any roles or users to your Amazon Managed Grafana during its creation. Rather, the roles and the users get assigned to the Amazon Managed Grafana on the fly upon the user's first successful login into the console. If you notice, in this approach, all the user entities like username, passwords, roles, and privileges are stored within your identity provider, which then serves as a single source of truth for your administrators to centrally manage users and access into Amazon Managed Grafana, thereby increasing your organizational security and prevents identity sprawl. Now next, I want to take our next few minutes talking about the co-build which we had with our ISV partners. I was fortunate enough to work with some of our identity partners to kind of build this integration. And I want to share a couple design and configuration details involved in this integration, which can then help your integration journey further. If you look at the Amazon Managed Grafana workspace, in order to configure our IDP, there are three URLs which are shared. That is the entity ID, the ACS or the callback URL, and the service provider URL. Now, if you map these requirements back to the IDP side, by closely working with our ISV identity partners like Okta, Ping Identity, OneLogin, and CyberArk, who built this dedicated SAML 2.0 app within their portals, we were able to simplify the user experience by reducing the configuration to two simple steps. When you check out the app, Amazon Managed Grafana app on the identity provider side, they hardly accept one or two simple fields like a workspace ID or the AWS region. Behind the scenes, using these two inputs, the identity providers are constructing the URLs necessary for the SAML assertions and API calls, thereby simplifying our mutual customer experience of logging into Amazon Managed Grafana and also reducing the chances of configuration errors. Now let's talk about the role details or how roles are configured on Amazon Managed Grafana. Today, in order to you can log into Amazon Managed Grafana as 3 different roles. You can log in as an admin, using which you can add, edit, create dashboards, data sources and users, or you could log in as an editor, using which you can edit dashboards and panels, or you could just use the viewer role where you can just assign or where you can just view the dashboards which are just assigned to you. Since Amazon Managed Grafana supports just-in-time provisioning, you can map the admin roles using the assertion attribute role for admin within the Grafana console. As you can see in my example, I'm using department as my assertion attribute role and admin as my assertion attribute value for configuring admin. What this means is, this is again a free text. You can use whatever free text you want. What this means is, as long as the IDP can pass this key value pair into Amazon Managed Grafana as SAML attributes, this particular user would then be granted admin access. And if you skip this section, the user will then be granted viewer access via which they can just view the dashboards. And as part of defaults attributes, there is a section called as additional settings within the Amazon Managed Grafana console, which you can skip, because by working closely with our identity partners, there are certain default values which are already initialized for assertion attribute name, assertion attribute login, and email, which Amazon Managed Grafana looks at by default. Now let's quickly map this on the IDP side. When it comes down to user mapping, it would be the exact same process that your admin would assign you an app on your IDP portal. Once the user is assigned to an app, you can pass the role attribute as a SAML assertion. And again, in this particular example, I'd use department. So you can see within this identity provider, the department value is set. And our IDBs have done a great job by initializing the default values for display name and mail, which Amazon Managed Grafana looks at. Again, these can be overridden on the Amazon Managed Grafana side if your use case permits. Finally, by using this simplified approach, you can now authenticate into Amazon Managed Grafana seamlessly and reducing the chances for any configuration errors. Now let's see how this fits into an SP initiated flow or the service provider initiated flow. User typically logs in to the Amazon Managed Grafana workspace by clicking on the Amazon Grafana workspace URL. And Amazon Managed Grafana would now respond back with a get SAML request. If you examine the SAML request by using a SAML tracer on your browser, you can see there is a destination field. This destination is nothing but the configured IDP's SSO URL. Since you have already configured your choice of IDP with Amazon Managed Grafana, Amazon Managed Grafana already knows what's the URL for destination via the SAML XML data or metadata URL configured. Next, there is an ACS URL or a callback URL. This is the URL which the identity provider will use to send back the post response to. The protocol binding in this case will be SAML 2.0 and HTTPS post, and issuer will be Amazon Managed Grafana, which is the SAML metadata URL. Now this request gets forwarded to the identity provider portal. This is where the user would log in to the identity provider using the IDP credentials. Upon successful authentication, the identity provider would now post a SAML response back to the browser. Again, if you examine the SAML response, we can see that there is a destination field. The destination field is nothing but the previously sent ACS URL, and the issuer in this case would be the IDP which issued this post response. But I want to take your attention to a particular section in this response, That's the bottom section where the default values are initialized by the identity provider. That's the mail and display name attributes. And to correlate with my previous screen, I'm using a SAML attribute as department. So as long as this department field has admin value, this particular user would then be granted admin access into Amazon Managed Grafana. The browser now forwards this request to the Amazon Managed Grafana console. This is where the just-in-time provisioning takes place, where the SAML assertions are examined, and upon the successful verification, Amazon Managed Grafana returns back the signature and a redirect, enabling the user now to log in to Amazon Managed Grafana workspace. Now let's see a short demo to see how this end-to-end integration works. I'll start off with an Amazon Managed Grafana workspace, and then I'll use auto-generated IAM roles for accessing the data sources. Then finally, I'll use an notification channel as Amazon SNS, and I'll use SAML 2.0 for my authentication, and I'll use ping identity as my identity provider in this example. And then I'll set up the ping configuration and attributes required. Finally, then we'll log in to the Amazon Managed Grafana URL using the IDP credentials. Once logged in, I'll connect to a data source like Amazon CloudWatch. Then I'll set up an alert. And once the alert goes off, I'll get a notification in my email. Now let's see how this all fits into a demo. I log into my AWS console and search for the Amazon Grafana app. I'll click on Create Workspace, and I'll provide my workspace a name and an optional description. I'll click on Next. In this demonstration, I'll be using SAML 2.0 as my authentication method so that I can integrate with the IDP. And I'll use service manage policy so that I don't have to create any IAM roles for all the data sources which I'll be selecting. I'll select all the native data sources which are available today, and also use the Amazon SNS as my notification channel. And then I'll quickly review the settings and click on Create Workspace. This usually takes a minute or two for the workspace to be created. Once the workspace is created, you'll now get the Grafana workspace URL. I'll copy this, which is needed for my IDP configuration. I'll click on Complete Setup. This is where I would configure the assertion attributes for the admin role, which I just spoke about. Just for the demonstration, I'll use the assertion attribute role as department and value as admin. Again, it's a free text. You can use whatever you want, but just ensure the same values get passed from your IDP. I'll skip these sections since at the end of this session, the presentation will see how they were populated with the defaults from the IDP side. I'll save the SAML configuration. And now I'll get back into my identity provider portal. I'll be using ping as my identity provider portal. I'll log into the identity provider portal as an admin and search the co-built SAML 2.0 app within the ping portal. Once I find the Amazon Managed Grafana app, I'll paste in the workspace URL which I just copied. Notice that I'll just need the workspace ID and the region. Behind the scenes, ping will construct the necessary URLs required. In order to map the attributes, you can see all the values are already defaulted. The necessary values have defaults. I'll add a static attribute for designating or authorizing my admin user. I'll use department and admin. There are different ways to do it at scale. Please feel free to refer to your IDP documentation. You can do it using member of or regex. Next, I'll assign the admin group. Then I'll save the configuration. Now I'll quickly check the configuration which I just set up. I'll copy the IDP metadata URL which is needed for the configuration on the Amazon Managed Grafana side. I'll verify the attributes. In order to improve my security posture, I'll use two-factor authentication and save. Now it's time to get back into the Amazon Managed Grafana console and complete this configuration. I'll paste the metadata URL which I just copied and quickly review the settings, and now click on Save Configuration. And now it's time to test the integration in action. I'll copy the workspace URL and open it in a private window. I'll be redirected to the welcome page of Amazon Managed Grafana. I'll click on Sign in with SAML. This now redirects me to the identity provider portal, that's Ping in this case. On the Ping side, I'll use my IDP credentials which I have used on Ping, and the app, Amazon Managed Grafana app, is already assigned to me, so I should be able to log in. Then I'll enter the passcode which I just received on my cell phone. Now I'll be redirected successfully, logged into Amazon Managed Grafana console. I'll quickly verify my user settings, and I can check in my login, email, and display name, and notice that I have logged in as an admin user, which means now I can add data sources. In order to add a data source, I'll navigate to AWS Services, select on AWS CloudWatch. I know I have resources running in US East region. I'll add the data source, and I'll go to settings and use the defaults which are already available, and click on Save and Test, which then verifies the data source. Now I'll go to dashboards, and you can notice there are out-of-the-box dashboards already provided with Amazon Managed Grafana. I'll import all the different dashboards for EC2, EBS, Lambda, CloudWatch, and RDS. Now I'll click on my EC2 dashboards. I should be able to see my metrics being generated from Amazon CloudWatch. I'll set the refresh rate to 5 seconds so that it's more real time. Notice you can see all the network details, disk details being populated. Now I'll quickly set up a couple alerts on this. In order to set up alerts, I'll go to alerts. Before that, I need to save the dashboard. In alerts, I'll need to set up a notification channel. So I'll provide a name for my notification channel. For type, I'll use SNS, but notice you can also use Ops Genie, PagerDuty, or Slack as your downstream notification channel. I use SNS. I'll paste my SNS topic, which I had created, and I'll use the IAM role and quickly verify the integration. And now, in order to configure the alert, I'll get back into the dashboard and click on Edit, which would then take me to this UI where I can choose my data source as Amazon CloudWatch, and I'll choose ESV202 since I know I have resources there, and I'll select metric query as my option, and for my namespace it will be EC2 instances, and for the metric name I'll use CPU utilization, and I'll also use a group by query so that I can group by instance ID which has the max CPU utilization. There's a SQL query which gets generated, as you can see. I'll change the period to 600 seconds. Then I'll go and configure alerts. This is the name which I can provide. I'll provide 10%. In order to make the alarm go off, I'll just use 10%, and I'll just set the threshold as below 10%. Set an alarm, this is just for the demo. Change the evaluation period to 1 minute. And now I'll configure the notification channel destination which I had just set up. In the message, notice I can use CPU utilization, but I can also use a dynamic variable that's $instance ID, which means all the instance IDs which had breached 10% CPU utilization will be sent to me in an email, which can then help my operations team. I'll quickly verify the settings and save the dashboard and get back into alerting. It will be in an unknown state for a few seconds, and then this should now flip to alerting in a couple seconds, to pending rather. Once it's in pending for a minute, it now flips to alerting. This is the time where an email would be sent to my SNS via my SNS. I can see the email with all the instance IDs which had breached the CPU utilization. But I want to quickly now navigate back to the Amazon Managed Console and see if the default values which I was speaking about have been populated. I'll see it's not there. I'll click on refresh, upon which I'll see the display name and mail being populated. This then shows how the assertions were asserted on the fly and then they were populated. Notice in this section there are other attributes which you can use, like editor role values or attribute organizations. Based on your requirements, you can use them. Now, to quickly recap, what did we see in this session? We saw how to centralize your observability with Amazon Managed Grafana. We also saw how to visualize, analyze, and monitor and set alarms across different data sources. We saw all the different data sources which can be plugged in with Amazon Managed Grafana. Next, we also understood that Amazon Managed Grafana is a serverless, secure, and fully managed service via which AWS does all the undifferentiated heavy lifting of taking care of your auto scaling, patching, and version upgrade needs. And finally, we also saw how to integrate an identity provider of your choice with Amazon Managed Grafana, which can then enable you to seamlessly authenticate and manage users and roles at scale via your trusted IDP. As part of next steps, I would encourage you to take a look at all the available public resources. I have the QR codes up there. You feel free to take a photo of it. There are different blogs and demos and labs which are available, which can then help you further enhance your observability journey on AWS. And I mean, if you want to take a photo. And finally, I would encourage you to check out the AWS Skill Builder website, where there is more than 500 plus free digital courses available in 16 different languages. And also, I would encourage you to check out AWS certification site and get certified. And join the AWS certified community, where you can take part in networking discussions and forums. There's a QR code here for you to grab. And finally, I want to thank you all for taking the time to attend this session. My name is Sunil Ramachandra. These are my contact details. If you have any questions, feel free to reach out. Thank you.